Hello guys, welcome to Maths by Budania sir. In this video, we are going to solve two important case study questions from the chapter 3D for class 12th board exam. We have already discussed one case study from this chapter. If you haven't seen that, then you can see it by clicking I button above. I will explain the concept and solutions step by step. Don't forget to subscribe and press the bell icon to get updates on all types of questions, be it MCQs, case study, assessment region, and descriptive 2, 3, and 5 marks. Pause the video, try the question yourself, and then watch the solution. Let's start. First question is saying, consider the following diagram where the forces in the cable are given. What we are given here is one tower which is standing vertically, and it is given that this is origin. This tower is standing at origin and along the z-axis. This is negative x, this is positive x, this is positive y, and this is negative y. Now this tower is held at its place by these three ropes 1, 2, and 3. Okay, and this point is marked as B, and this point is marked as A, and this point is marked as C, and top of this tower is marked as D. So first of all, what we will do, we will write the coordinates of these points. So firstly, we will write coordinates of point A. So coordinates of point A, we can easily see that it is at 8 meter distance from y-axis. So its x coordinate will be 8. Now this point is away 10 meters from x-axis towards the positive y. So this coordinate will be 10. And for z coordinate, we can observe that z coordinate will be 0 because this point is lying in xy plane. Similarly, we can write the coordinates of this point B. Now, for the coordinates of point C, we can easily see that this point is at 15-meter distance from y coordinates toward the x coordinates. So its x coordinate will be positive 15, comma its y coordinate, this point is 20 meters away from x axis towards negative y axis, so it will be minus 20, and z coordinate will be 0. This point lies in xy plane. Now last and final coordinates of point D. So we know that this point D is lying on z axis, so its x coordinate will be 0, y coordinate will be 0, and z coordinate will be, this point is at 30-meter distance from the origin, so the z coordinate will be 30. Okay, now let's proceed to the questions. Question number 1 is saying, find the equation of line along the cable AD in the Cartesian form. Okay, we have to find the equation of this line AD. Now let's assume that this is x1, this is y1, and this is z1, and it is x2, y2, z2. Now we know the formula to find the Cartesian form of line when 2 points lying on it are given. So we know the formula, that is x minus x1 upon x2 minus x1 is equals to y minus y1 upon y2 minus y1 is equals to z minus z1 upon z2 minus z1. Okay, so now we will put these values. So x minus x1 is 0 upon x2 minus x1, that is 8 minus 0 is equals to y minus y1, that is 0 upon y2 minus y1, that is 10 minus 0 is equals to z minus z1, that is z minus 30 upon z2 minus z1, that is 0 minus 30. So now we can write it as x upon 8 is equals to y upon 10 is equals to 30 minus z upon 30. So this is the answer. Next it is saying, find the length of the cable DC. Okay, now in this part, what we have to do is to find distance between C and D. And we know the formula of distance between 2 points in 3D. This we have learned in class 11th. You should know that. Okay, now we know the formula. Let's say this is x1, this is y1, this is z1, this is x2, y2, z2. Whichever point you want to take x1, y1, z1, you can take, and other point will be x2, y2, z2. Okay, so we know the formula, that is the distance between these 2 points CD, that is equals to, the formula is as follows: x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. From here we can write CD is equals to, now put the values. Now x2 is what? That is 0. minus x1 that is 15 square plus y2 is 0 minus y1 is minus 20, so it will be plus 20 square plus z2 is 30 minus z1 is 0 whole square. From here we can solve it. Minus 15 whole square that is 225 plus 20 square 400 plus 30 square that is 900. From here we can write it as 9 for 13 13 15 25. Now taking 25 out of this under root we will get 5 under root 61 meters, and this is the answer. Now in question number 3, it is asking find the vector dB. So this is point D and this is point B. So we know that vector dB will be equals to position vector of point B minus position vector of point D. Okay, now we can write it as dB vector will be equals to, let's first write the coordinates of B point, that is minus 6 comma 4 comma 0 minus 0 comma 0 comma 30. Now after subtracting these coordinates we can write minus 6 I cap plus 4 j cap and minus 30 k cap, and this is the answer. Okay, now in question number 2, it is saying two motorcycles A and B are running at speed more than allowed speed on the road along the lines. First line is this, second line is this, respectively. Okay. Based on the above information, answer the following questions. Question first is asking find the Cartesian equation of the line along which motorcycle A is running. Now we know that motorcycle A is running along this line. So let's write this equation of the line in standard form. Let's say 0 I cap plus 0 j cap plus 0 k cap plus lambda times of I cap plus 2 j cap minus k cap. Now we know that coefficient of I cap is x1, coefficient of j cap is y1, coefficient of k cap is z1, and coefficient of I cap here is a, this is b, and this is minus 1 will be c. Now we know the formula in Cartesian form, that will be equals to x minus x1 upon a, that is equals to y minus y1 upon b equals to z minus z1 upon c. Now as we have written the x1 y1 z1 abc, we can simply put the values. So x minus 0 upon a is 1, is equals to y minus y1, that is 0 upon b, that is 2, equals to z minus z1 0 upon c, c is minus 1. Okay, now from here we can write the answer, that is x by 1 is equals to y by 2 is equals to z upon minus 1. And this is the Cartesian equation of the line along which motorcycle A is running. And this is the answer. Clear? Now question number 2 is asking find the direction cosines of line along which motorcycle A is running. We know that these A, B, C that we have used in answering question number 1, these are basically direction ratios of this line. Now we can write that drs of required line, that is 1, A is 1, that is coefficient of this I cap, B that is 2 comma C that is minus 1. Now what we have to find is DC's, direction cosines. Now we know that to find DC's, what we have to do is divide this dr by the magnitude of this vector whose drs are these. Okay, so what we have to do is we just divide drs by magnitude of this vector. So magnitude of this vector is 1 square plus 2 square plus minus 1 square, 2 upon under root 1 square plus 2 square plus minus 1 square, comma minus 1 upon under root 1 square plus 2 square plus minus 1 square. Okay, from here on simplifying we can find the DC's, that is first direction cosine is 1 upon under root, simplifying 1 square 1 plus 4 plus 1, that is under root 6, comma 2 upon under root 6, comma minus 1 upon under root 6. This is the answer. Clear? Okay, now question number 3 is asking find the shortest distance between the given line. Okay, this is typo, so it is saying find. Okay, find the shortest distance between the given lines. Okay, firstly what we will do is we will write these two equations in standard form. Okay, so equation of first line, that is r vector is equals to 0 I cap 0 j cap plus 0 k cap plus lambda times of I cap plus 2 j cap minus k cap. And the equation of second line is, that is r vector is equals to 3 I cap plus 3 j cap plus 0 k cap plus mu times of 2 I cap plus j cap plus k cap. And now we know that we can say this is a1 vector plus lambda times of b1 vector, and this is a2 vector plus mu times of b vector. Now why I have written these equations in standard form? Because we will be needing a1, a2, b1, b2 in the distance formula. That is, distance d is equals to mod of a2 minus a1 vector dot b1 vector cross b2 vector upon magnitude of b1 vector cross b2 vector. Now firstly what we will do, we will find this numerator, because if this numerator becomes 0, we know that distance between two lines is 0 when two lines intersect each other. Okay, so let's find a2 minus a1, a2 vector minus a1 vector, that is equals to a2 is what, that is, let's say 3 comma 3 comma 0 minus 0 comma 0 comma 0. From here we can write 3 I cap plus 3 j cap plus 0 k cap. Okay, next is what, b1 cross b2. Now we will find the cross product using determinant form. For determinant form we know that what we have to write is here I cap j cap k cap. Now second row will be the coefficient of I cap, j cap and k cap of b1, that is 1, comma 2 and minus 1. And third row will be the coefficient of I, j, k cap of b2 vector, that is 2, 1 and 1. Okay, now solving the determinant along the first row, we will get I cap into 2 and 2 minus minus 1, that is plus 1, minus j cap 1 minus minus 2, that is plus 2, plus k cap, that is 1 minus 4. So from here we will get 3 I cap minus 3 j cap and minus 3 k cap. Okay, now what we have to do is we have to take dot product of these two. So dot product of a2 minus a1 vector dot b1 cross b2 vector, that is equals to 3 I cap plus 3 j cap plus 0 k cap dot b1 cross b2 is 3 I cap minus 3 j cap minus 3 k cap. Okay, now from here on multiplying coefficient of I cap, j cap and k cap and adding them, what we will get, that is 9 minus 9 plus 0, that is equals to 0. Now as this denominator of this distance formula is 0, so the distance between these two lines will be 0, means these two lines are intersecting lines in 3D. So from here in words we will write, therefore shortest distance between the given lines will be 0, means these lines are intersecting lines. Okay, here we end the video. If you liked the video, hit the like button, share this video with your friends so that they can also get benefited. See you in the next video. Bye bye.